Hello everyone. In the previous video, we have discussed what is heat and what is temperature is, and I told you that heat is the cause, temperature is effect, and that temperature measures hotness or coldness of a body. To measure this temperature, we have different scales. Among them, the popular scales are something like we have a centigrade scale, we have a Fahrenheit scale, we have a Kelvin scale. We have another scale called something like raumer scale, or you can have your own custom scale, whatever you can name it, right? So how do they works, right? So whatever the scale that you use, you are trying to measure the temperature of one body. So the value looks like different, but the actual temperature is same because you have used different scales. It appears like different for you because whenever you see something in a different color glass, it appears in a different color. That doesn't mean body has changed its color, rather your frame has changed. Same in this case, right? So in a centigrade scale, see, if we are having a centigrade scale, the lower temperature that you measure is 0. The upper temperature that you measure in the scale, upper fixing point, people call it like, is 100 degrees centigrade. So we call this as lower fixing point, and you call it like upper fixing point. So if you are trying to measure a temperature, particular temperature, that you call the temperature as degree C. How can you show that relation? And you have, say for example, a different scale, that is a Fahrenheit scale. Be careful to understand that Fahrenheit scale doesn't start with a 0 like centigrade scale. Rather, it starts at 32. It doesn't ends at 100 degrees. Rather, it is ending at 212 degree Fahrenheit. That upper fixing point is 212. So if you notice carefully, this lower fixing point to upper fixing point, the intervals are 0 to 100. That is, the scale has divided the lower to upper fixed points as 100 parts. But here in Fahrenheit scale, from 212 to 32, it is divided into 180 parts. So the value automatically looks like different. Similarly, the Kelvin scale, it starts with 273 degrees centigrade and ends at 373. Of course, it is again divided into 100 parts like the centigrade scale, but the starting, the lower fixing point and the upper fixing points are different. So here you measure the temperature, you call it like Fahrenheit. Here you measure the temperature, you call it like K. There is another scientist called Raumer. He has designed, everybody can design their own scale, right? There is nothing. Only problem is somebody is willing to follow your scale. That's it, right? If there are takers, then that's fine. So this Romer scale starts with 0, lower fixing point. Its upper part is 80. That means this is divided into 80 parts. So there will be a particular reading, you can call it like R. R, as I told you can have your own scale. You can fix your lower fixed point of your choice. It could be 10, 20, 30, 11, 18. What the hell you like, you can fix it. But of course, you only know it. Nobody else know it. That's the problem. And this is upper fixing point. This also you can fix into any parts. Thus, you are dividing the entire scale into certain parts as what? Upper fixed point minus lower fixed point. Then you will get a certain value. You can call that as some X, or you can put your own name to that scale. No problem. But though you are using different scales, you are trying to measure the temperature of the same body. Thus, these scales are related to each other because you are measuring the same temperature. So, how do these readings are related? Relation between these them is very simple. What is that relation is? reading that whatever you are measuring minus lower fixed point by upper fixed point minus lower fixed point is constant in different scales. Do you understand what's the meaning of that? Let me write an equation so that you can actually understand. Say in the case of the centigrade scale, let you call that reading as C minus lower fixing point of the centigrade scale is 0 by, let me call the upper fixing point of the centigrade scale is 100 minus lower fixing point is 0. That's the value of the centigrade scale. And when you come to the Fahrenheit scale, let you call that reading as F minus lower fixing point of the Fahrenheit scale is 32 by upper fixing point is 212 minus again lower fixing point is 32. And when you come to Kelvin, K minus lower fixing point is 273 by upper fixing point is 373 minus lower fixing point is 273. When you come to this raumer scale, you call that reading as R, lower is 0, upper is 80 minus lower is 0. And you design your own scale, let you call reading that as X, lower fixing point by upper fixing point minus lower fixing point. Using this core concept that this is constant and we have derived this formula, you can use this formula and derive any relation, any temperature at any of the scale. Once you know the temperature in one scale, you can automatically find the temperature in other scale, isn't it? So if somebody asks you if it is some 50 degrees centigrade in centigrade, what is the value of what is? If somebody asks you a question, what is the question that somebody is asking you? What is 50 degrees centigrade in Fahrenheit is how much? So I can simply use these two. C is given for you as 50. So 50 minus 0 by 100 minus 0 equal to F, you have to find out. F minus 32 by 212 minus 32. So 50 minus 0 is 50, 100 minus 0 is 100. F minus 32 by 212 minus 32 is 180. So this is 25s and 29s. This is 5 tenths. So what is remaining? 10 equal to F minus 32 by 9, isn't it? Then F minus 32 is 90. So F equal to 90 plus 32. That is 122 degree Fahrenheit. So 50 degrees centigrade is 122 Fahrenheit. It is obvious that as the number of the divisions are more, the reading appears like to be more. That doesn't mean that is big, both are the same body, right? That's why a human body's temperature in centigrade is somewhere 36, whereas in Fahrenheit that is somewhere 98.6, something like that. That 98.6 is not high when compared with 36 degrees centigrade of a human body. It is just a different scale, so it appears like high for you. That's how we can do different kinds of problems and get different answers to find the temperature. Just to continue further, C minus 0 you can call it as difference in temperature by 100 minus 0 as 100. F minus 32 as difference in Fahrenheit. 212 minus 32 is 180. K minus 23 is delta K by 100. Delta R by 80. Delta X by upper fixing point minus lower fixing point. So to find specific temperature, we use this relation. To find difference in temperature, we use the second relation. Do you understand what's the meaning of that? I will show you what is the meaning of that is, right? Let us say, if someone say temperature of a body is increased by some 20 degrees centigrade. How much it is increased in terms of Fahrenheit? If somebody has asked you that kind of a problem, I can simply use this relation. What is that? Delta C by 100 is equal to delta F by 180. That is delta C by cancelling with 20, 25s are 100. Delta F by 29s are 180. But this delta C is given to you as 20. So 20 by 5 equal to delta F by 9. This is 4. So delta F equal to 9 into 4. That is 36 degree Fahrenheit. So a rise in temperature of 20 degrees centigrade is equivalent to the rise in temperature of 36 degree Fahrenheit. Simply the Fahrenheit, as the Fahrenheit has large number of units, 180 units, value appears like more when compared with the centigrade. In a similar way, we can find a relation between any of the two scales as it is being explained here. That's it. Thank you for watching.